Director at Tina's Wish, and I'm really excited to welcome you all here. As you just saw, we are recording today's session. That's just because a few people are not able to join us, and we want to be able to share this incredible program with others afterwards. Tina's Wish was founded in 2008, both in memory and in honor of Tina Brosman, who unfortunately succumbed to the disease way too young in life because she didn't know early enough. And really at her request, and thanks to the incredible support of her friends and the restructuring community, we have been able to continue her request, and that is to find an early detection for ovarian cancer so that all families and women can know early and know hope. So that has been really the genesis of Tina's Wish. Annually, we're currently funding $1.6 million a year in scientific research across 11 incredible projects, and we'll be able to hear from one of them this morning. In the absence of an effective screen, it's really important that all women and all those that have special women in their lives are aware of the signs and symptoms of ovarian cancer. And so you'll see on the screen those most prevalent signs and symptoms, and we really encourage anyone who's experiencing those signs or symptoms to seek medical attention if they persist for greater than 2 weeks. And we also encourage anyone who might have ovarian or breast cancer in their family to speak to their doctor at their next visit to just identify whether they might be at increased risk for this disease. Also in the chat is a link to this image on our website that you're welcome to download and share with others at your convenience. Because in addition to the science we fund, it's important to us that we create awareness about a disease that often goes unspoken. And lastly, I just wanted to bring to your attention, a week from tonight, September 30th at 7:30 p.m., we're really excited to be hosting our second virtual benefit. While we love being in person, we recognize that we still need to be cognizant of all the safety concerns out there. So we will be hosting, I promise it's only a 30-minute virtual benefit, but it promises to be really meaningful and interesting. David Faber, who's co-anchor of CNBC's Squawk on the Street, will be our co-host for the evening. We'll be also featuring Ash Fu, who's a supermodel and ovarian cancer survivor, and her very inspiring story. And the band NED, No Evidence of Disease, which is comprised of gynecologic oncologists, will be performing as well that evening. And most importantly, we'll be honoring Joelle Frank for really her leadership and her mentorship in our community and all that she does for women, and particularly this year, what she's been doing for Tina's Wish. And we're really honored to be honoring her. So I do hope you'll tune in. In the chat function is a link in which you can register for that event, which again is next Thursday evening. So without any further ado, I want to introduce to you Kimberly Cantor, who is going to be our moderator for this morning. She is an incredible supporter of Tina's Wish and a member of our Leadership Council. Thanks so much, Kimberly, for hosting.
Thank you, Beverly, and good morning to everyone. I'm honored to be today's moderator of this researcher roundtable. I came to Tina's Wish through basically word of mouth. I had had multiple interactions with very close friends who have had this horrible disease. In 2009, my really good friend passed away from ovarian cancer. In 2011, my roommate from college passed away from ovarian cancer. And then not long thereafter, my closest friend and roommate from college as well I found out she had stage 3C ovarian cancer. At that point, I realized that to the extent I was going to be providing time or money to an organization, I wanted it to be involved with an effective method to detect ovarian cancer early on. And there is no other organization than Tina's Wish that I feel like is doing as good of a job doing that. Saying that, 4 of the researchers that are on this panel today are contributing to this, and hopefully they'll be the ones to find the method to detect an early screening for ovarian cancer. We'll be hearing today from Dr. Ronny Drapkin from Penn Medicine, Dr. Dan Heller from Memorial Sloan Kettering Cancer Center, Dr. Ie-Ming from Johns Hopkins Medicine, and Dr. Rugang Zhang from Wistar Institute. A few technical comments about today's platform. For those of you who already know this, this is an opportunity for you to answer or ask any questions you have, and they will be answered during the question and answer period at the end. You can do the questions in two different ways. You can write them in the chat during the program, and at the end, we'll answer those questions that are in the chat, recognizing that what you provide on chat is visible to everyone. To the extent you would like to be anonymous, then you can just pull the drop-down chat area and choose my name and send me the question directly, and you'll remain anonymous. During the last 5 to 10 minutes, we'll be answering those questions. If you prefer to ask questions visibly or verbally, you can use the raise the hand feature. And for those of us who are new to this, it's just the hand symbol at the bottom of the Zoom screen. And we'll answer your questions at that time as well. We'll wrap the session up by 9:15 as promised. And I look forward to hearing what these amazing researchers have to say. Saying that, I want to welcome the researchers, and I'm excited to ask a few questions to each one of you. The researchers are, these 4 researchers are collaborating from different institutions on the integration and advanced genomic and bioengineering approaches for the early detection and prevention of ovarian cancer. The first question I have is for Dr. Drapkin. How did this group of incredibly talented researchers come together?
That's a great question. And I want to first thank you for having us today. It's a real pleasure for us to be part of this consortium and part of Tina's Wish. Let me begin by saying that I think collaboration is a funny and tricky thing. It sounds like it's sort of something simple that you can just bring 2 people together and they can work, but oftentimes it really requires an equal enthusiasm to address the problem together. And I was very lucky in thinking about putting this together because I had known Dr. Ie-Ming Shih at Hopkins for many years, and I was familiar with his work, and we've both been very interested in trying to understand how these ovarian cancers begin in the fallopian tube. So that was already someone I knew and I respected. Dr. Dan Heller was someone that I got to meet through Tina's Wish, and Dan Heller is probably one of the premier bioengineers in this space, and I was fascinated by some of the things he was doing with nanotechnology and thinking about early detection. And then Rugang Zhang, I had the pleasure of not only knowing prior to my move to Penn, but when I moved to Penn, we became neighbors. And so I was able to work with him, and he's a phenomenal top-notch researcher. And so in thinking about how to bring an all-star team together, it wasn't hard to think about these 3 individuals and hope that the collaborative spirit would work out. And thank God it did for us. I don't think I heard your question. You might be muted.
Sorry, I keep hitting mute and I keep forgetting to unmute it. But what is the goal or the objective of the consortium grant?
Yeah, so we had 3 major goals, and we wanted to really take advantage of all the expertise within the group. So one of the goals was for Ie-Ming Shih and I to continue really trying to understand the precursors for ovarian cancer that begin in the fallopian tube. And the hope was that we could understand these genomic and molecular elements of these precursors and then translate them into a detection test. And Ie-Ming had been for some time working on this idea that if you get as close to the source as possible, right, what we call tissue proximal, you might be able to sample material there that would at least perhaps serve as an early detection tool. He developed what's called the pap gene test, where you take a pap smear, which I want to emphasize is only useful for detecting cervical cancer, but the fluid in the pap smear might be reporting out what's happening higher up in the female reproductive tracts, perhaps in the fallopian tubes. And so the idea was that if we collect this pap smear fluid and look for alterations that we see in the fallopian tube, maybe, right, those would be present in that fluid that sheds down through the female reproductive tract normally all the time. And so that was goal 1, is to really try to develop this early detection test and take advantage of our understanding of the precursors to really refine that test in the pap gene approach. The other one was to take advantage of Dan's expertise and see if we could actually develop a nano sensor. So Dan had been working with these nanoparticles, nanotubes, and had been able to develop these really, almost microscopic little detection devices where we could look for specific biomarkers that we had identified in ovarian cancer or even in precursors, and then implant these sensors into the female reproductive tract, ideally as close to the source as possible, so that once the biomarker bound to the sensor, it would change its frequency in the detection of that nanotube would be a viable approach for us to see whether that was a biomarker was being released at that site. So an implantable nanotube was the second approach. And then the third approach is really taking advantage of Rugang and Zhang's expertise, which is really understanding tumor initiating cells, right? These cells begin in the fallopian tube. So if we understand how they do that, the question was, can we eradicate them, right? So really prevent the cancer from ever getting started. And that was really the third goal. And so it was really a detection approach in the first two aims and an eradication approach in the last one, all sort of pulling together the engineering, the molecular biology, and the different expertise to try to make that happen.
Well, kudos to you, because it sounds completely confusing to me, but I recognize that each one of you is an expert in your field, and I'm so grateful to have you part of the research consortium grant. Moving on to Dr. Heller, why is this research so important to the early detection of ovarian cancer?
So, as probably many of you know, and thanks so much, that if this disease can be detected at earlier stages, it can really save lives. And if right now, if it's detected at stage 4, it's much more difficult to treat, and really there's very little potential for cures at that stage. Whereas if one can detect it, when it's not spread, not metastasized at earlier stages, one could really the treatments are much more effective. And so by building this consortium together with this goal in mind, we really have been excited to address that question and that problem. And really, that's what Tina's Voice is doing, which is amazing.
Yes, it is amazing. I had the opportunity to go into your lab and see your nanotechnology process, and it's somewhat of a mad scientist approach, and I think it's really quite cool. And hopefully at some point, everyone's gonna be able to see this and experience this in the clinician's office. Saying that, and I highlight this without hesitation, I think Tina's was one of the first organizations to really pull together a collaborative approach to a development of a outcome. Prior to COVID, Tina's Wish was collaborating amongst multiple different organizations and recognized the benefit of that. Saying that is a current buzzword in the industry because people are hearing it more and more with COVID. Can you please explain why it's important to you and how this particular collaboration came about?
That's been key for us, especially me, because without collaboration, we'd be lost. So my background is engineering and chemistry. So I came, my whole lab started at Sloan Kettering with the idea of developing new technologies to address cancer. But we, and one big component of my lab is building sensor technologies. And we hadn't, so my background isn't really in cancer. But really, we knew that if we could build a sensor with the right to address the right questions, we could really make something that made something amazing. And so when we first when I first got involved in Tina's Wish, it was with Doug Levine, who's on the call, who's the previous head of the scientific advisory board, and that really brought my lab into the ovarian cancer space. And now we have multiple projects in detecting ovarian cancer because of that. And so when we started working, he said, we need to detect ovarian cancer early. Can you make a sensor? And we said, that's amazing. That's exactly what we want to do. And then really we've dedicated a large part of my lab's effort and my effort to detecting ovarian cancer since then. And this consortium has been amazing because we've had the really direct contact with people who can really tell us about what we needed to do to make a sensor that really will work and answer questions for the disease and address the needs of patients. I've been working a lot with Ronny to be able to get samples from patients, fluid samples, to be able to make our sensor work a lot better. We're basically now using machine learning and with our sensor to be able to detect many types of markers in an implantable device. And my postdoc from my lab's V is also online, who's been doing this, the guy working in the lab. So really having this consortium has really pushed our work forward a lot faster than it would have done otherwise. Oh, you're muted again.
Dr. Drapkin and Dr. Shih have provided you some of the resources needed in order to actually utilize and determine how your technology works. How have you been working with Dr. Zhang?
We have been we've been thinking that it's been about learning more, understanding the biology better, and getting samples, understanding the biology better, and figuring out how to integrate this into something that can be put into a patient, and then to use our sensor to understand the disease better by figuring out when these markers appear in the body and in different locations of the body. So it's really been kind of getting some of the biology and some of the clinical side and samples from from all of these people.
Great, thank you so much, Dr. Heller. Dr. Zhang, as it not specifically related to the consortium grant techniques, explain the challenges that you've experienced during COVID and how you've been able to work together and move it forward.
Yeah, so that's a great question, Kimberly. So I think obviously everybody in the scientific community really faced uphill battle in the past 1.5 years, right? Most of the institute, if not all of them institute, were closed for several months. So this by itself is a huge challenge for individual lab. But in particular, with regard to consortium type of collaboration, that's posed an additional challenge, right? For instance, so obviously Ronny and I across the street with each other in the before pandemic, I just sent my postdoc across the street to get stuff from his lab, right? But during pandemic, obviously we sort of never closed, in part because we are designated as an essential business, quote unquote business, because we're developing COVID-19 vaccine. With that being said, the pen was closed. So during that time, we were discussing a critical experiment whereby we will get the mouse and then perform the experiment. But because the pen is closed, although we cross the street with each other, we cannot get the specimens, right? So that's really, frustration might be an understatement, but with that being said, right? So that's the challenge we have to deal with. With that being said, move forward, I think we're going to just have to work harder to make up the time we lost, right? And I think essentially that's exactly what we are discussing with Ronny, for instance.
So physically not being in the same facilities, obviously because of COVID, causes some problems. Yeah. But outside of physicality of it, you have intellectual property associated with virtually every institution as for the 4 collaborating entities. Mm-hmm. How do you work amongst the 4 institutions, and how do you overcome these issues that the different organizations may feel are, their property?
Yeah, so that's another great question. So that's the beauty of this consortium is that we can solve these issues at the forefront, right? So essentially during the grant negotiation stage, so each of the 4 institutions come together and go through the terms with Beverly and her team to lay out what a path forward. I think in light of this, Tina's wish is really fantastic in managing this process, so that we actually can spend our time focused on science instead of deal with the front end of the business, if you will. Obviously, that's important from the institutional standpoint view, but for our passion is really make discoveries that eventually benefit the earlier detection or prevention. That's essentially the core of our duty, if you will, with regard to the mission of the Tina's Wish.
Right. It's
Yeah.
wonderful to find out that Tina's Wish is the is actually making sure that you can focus on what you want to focus on and what your passion and expertise is, as opposed to the back office administration of it all.
Exactly.
An organization, Tina's Wish, is one of the few reasons why this type of collaboration can happen.
Exactly.
Now, Dr. Shih, it's kind of the $1 million question. This grant's a 3-year grant. You're obviously involved with it in the middle of this grant at this point. Kind of when do you think that we're going to see early detection in a clinician's office?
Yeah, I think this is a very good and a practical question. And the early detection of ovarian cancer has been believed to be the hard problem in medical science. And the challenges concern the number 1, technology, number 2, biomarkers, number 3, access performance, number 4, regulatory hurdles, and finally, the cost. Just to name a few. So the good news is that scientists from both academic and industrial sectors are making big progress in recent years toward this goal, which is to deliver an early detection test to the physician's office. So every woman has the chance to for detecting their ovarian cancer much earlier. So all things considered, in order to answer this question, it's difficult to predict when the dream will come true. But one thing is certain is that we will witness major breakthroughs in coming years that will eventually lead to the maturity of the test in the next, I would say, 5 to 7 years. So I think this is Tina Wish function is great. And this kind of team projects focusing on early detection will accelerate this progress into delivering a very good test, reliable test for early detection in the next decades. So finally, I would like to say that we would like to thank the Tina Wish Foundation and all of you to contribute to our research and our team science project. And I think, again, I think this effort will greatly accelerate the goal for the early detection. And thank you all very much.
Thank you, Dr. Shih. At this point, we were going to open it up to questions for the participants and via chat or hand raising. And I haven't seen any questions via chat, but I'm not sure, Beverly or Caroline, if you've seen any.
Dorothy's raising her hand.
Oh, thank you. Dorothy.
Yes, and particularly relative to the device, who would allow that to happen to them, and how would they be identified? Would this be people who've already been identified as BRCA positive or something along, or at high risk? How would you get people to do that?
So in terms of the implant, basically like an IUD-like sensor that we're working on right now, which is the earliest kind of form of the sensor, it would be with patients who have a risk factor, either BRCA positive or family history, and in this case, because it's right now we're building this into an IUD, it would be patients who haven't had a hysterectomy yet. And so right now, that's kind of how we're starting. We're hoping in the future to kind of put this into a different form factor that can monitor for markers continually in a larger number set of people.
Thank you.
Thank you. Thank you, Dr. Heller. Elizabeth Jones has a question. Okay. She says that in her recent research, there are several types of ovarian cancer with different recommended treatments. Does the current research address all forms?
I guess I can start. Absolutely right. There are at least 4 and actually more subtypes of ovarian cancer, and as alluded to in the question, that they behave differently clinically, they present differently, they look different under the microscope. We focused on the most common form in developed countries, which is what we call high-grade serous carcinoma. This accounts for greater than 70% of all forms of ovarian cancer. And so we felt that this was the one that we would want to target with these efforts, because we felt, because of its sort of prevalence in this setting, that we would be able to have the greatest impact. So you're right that there are other subtypes. They're a little bit differently developed in terms of where they begin, how they respond to therapy. I don't know if Ie-Ming wants to comment a little bit more on the other subtypes. He's done a lot of nice work in this regard.
Yeah, thank you, Ronny. I think there are different types of ovarian cancer, as Ronny just told us. And so the fact is, for the high-grade serous carcinoma that Ronny referred to, is the most common, and the most importantly, this high-grade serous carcinoma usually present at a higher stage, like stage 3C, when the curable option is really limited. So that's why we focus on high-grade serous carcinoma, because early lesions are really difficult to detect. So for the other type of ovarian cancer, we call type 1, like endometrial, mucinous, etc. And the good thing is that this tumor tend to be early stage when they are presented to the patient and clinicians. Usually stage 1 with a big cyst. So after the removal of the cyst containing the ovarian cancer, and basically the patient can be cured. Of course, there's another 50% of this another rare types as advanced stages, and we don't have the good tool at this moment to detect them, because number one, they are not so common. Number two, we don't have biomarkers. So our idea is, when we are able to design the best approaches for detecting the most common one, high-grade serous, then we can come back to study this rare type of tumor for early detection.
Thank you. Dr. Drapkin, I have a question for you, and if you could address it to any one of the three collaborators, depending on who is a better respondent. Is it the challenge of this disease, having the ability to detect it early, primarily because it's not actually a cancer in the ovaries, it actually is a cancer that starts in the fallopian tube? Is it because the fallopian tube aspect of it that the challenge here?
Yeah, no, great question. I think, for, gosh, I want to say decades, we were thinking of this disease as an ovarian cancer, and to the point that Dan made earlier, a lot of the focus was trying to find these early precursors in the fallopian tube. So when the BRCA genes were cloned in the mid-90s, so we're talking about over 25 years ago now, that was a huge breakthrough in the field, because it gave us an opportunity, right, to really identify patients that are at high risk. It also gave us the opportunity to offer them prophylactic surgery, so removing the tissue at risk. And the way we used to do that, really focusing on the ovary, was to take out the ovary and the fallopian tube, because they sort of come out as a unit together. And we would look at the ovary in its entirety under the microscope, looking for these, what we call the cult, hidden early cancers, and rarely ever found anything there. But by early 2000s, reports in the Netherlands and in the US started to kind of suggest that there were some funny looking cells in the fallopian tube. And it was sort of left there as something's happening in the tube. We're not really sure what's going on. But it's interesting that we're looking for early cancer, and yet we're finding things in the tube. And I was lucky to be working with Dr. Christopher Crum at the Brigham and Women's Hospital up in Boston at the time, right when I was finishing my fellowship and starting my own lab, and had a lot of conversations with him. And we wondered whether we were missing the boat on what's actually happening here. And no one had ever systematically kind of looked at the fallopian tube. And so he developed with his fellows an approach to systematically examine the fallopian tube. We call this CFIM now, because it stands for sectioning and extensively examining the fimbriated end, the very distal end of the fallopian tube, and along with the rest of the fallopian tube. And when they did that in these women who were having prophylactic surgery because they had high risk BRCA mutations, they found that all these precursors that we've been looking for in the ovary were actually in the fallopian tube, the nascent cells that developed into an in situ cancer that then invaded and became metastatic. That whole process, that morphological continuum that we had been searching for, in the ovary was actually happening in the fallopian tube. And that was sort of the flip the table moment where we realized, oh my God, we've been looking in the wrong place this whole time. And since then, there's been not only validation of all those observations, but tremendous work in laboratories like Ie-Ming, Shih, and others. Our group has tried to contribute as much as we can to that, trying to really understand how is it that the fallopian tube is so susceptible to transformation? What are the factors that lead to that? How can we detect it early? Can we intervene to eradicate it before it becomes the clinical problem that it becomes? And to your question, these lesions in the fallopian tube are microscopic. You really can't see them by eye. Even if you were to look at them as a surgeon, for instance, when you're looking there in the operating room, you wouldn't notice anything abnormal about the fallopian tube. But even at that point, those early lesions may have already shed to involve the ovary or the abdominal organs in microscopic ways. And so it is the problem, right? That they do seem to begin in the fallopian tube, but they can shed very early before they're visibly there, and they can really grow for interesting reasons, in the ovary very rapidly, in the abdominal cavity very rapidly. And that's another question we're trying to understand, is why is it that they are so aggressive growers once they leave the fallopian tube as well? But that's a challenge. So if we can find these early microscopic lesions in the tube, that's when we have the best opportunity to intervene surgically and provide cures.
Thank you. It's obviously a significant challenge. Dorothy has a question, but I'm gonna ask that after Elizabeth Jones' question. Thank you all for your questions via chat, by the way. But to add on to the question related to what you were just talking about, Dr. Drapkin, is it a BRCA1 or BRCA2 gene that's primarily marker being researched, or is it just what gene is primarily being researched?
So we think of high risk as any genetic predisposition. The first two genes were BRCA1 and BRCA2, as I mentioned, discovered over 25 years ago. The technology for us to define other high-risk genes has exploded in the last 10 years. And so nowadays, when people are sent for sequencing because they have a strong family history or because they get diagnosed with ovarian cancer, we are actually looking at what's called panel testing, where you can actually sequence a whole collection of genes, which we believe are all working in what we call DNA repair, and trying to sort of repair the genome from the various sort of physiological and external factors that mutate our DNA. And so BRCA1 and 2 are sort of the poster childs, and they're the most common, the most highly penetrant versions of these high-risk genes, but there are definitely a whole host of other genes that do confer risk, and now we're aware of them now. And so we are addressing those as well.
Great, thank you. So moving on to Dorothy's question, what would be the clinical trial and regulatory process for an implantable device? I think this is a Dr. Heller question. And how do you prove efficacy?
Yeah, thanks much, Dorothy. I'm impressed by your questions, because some of these certainly we're working to answer those exact same questions. Right now, we're in the stage of actually putting these implants into the uteri of patients undergoing hysterectomy surgery to prove basically efficacy and safety to the tissue before they go into an actual patient. And so right now we're doing we're doing work in the surgical suite. And so this is the kind of the earliest stage of leading to a clinical trial, which in that case would also be in the surgical suite for a short implant time. But then for understanding the idea with the sensor is that it can reside there for a longer amount of time in a patient, and that it can accrue marker and accrue signal and get to something that's much more sensitive and local than we can get right now. And so then the idea is to continue with clinical trials to a larger set of patients that have have risk factors.
Thank you. I want to thank all four of the collaborators and doctors on this panel this morning. It's not often that you get to ask even one doctor a question associated with symptoms and methods of their process. But today has been an opportunity for us to ask all four of you, and it's so greatly appreciated. To the extent anyone has any other questions, you can raise your hand or put in the chat, but otherwise we're going to wrap it up slightly early and be respectful of the doctor's time and everyone else's time on this call. Dorothy has one other quick question prior to us wrapping up. And, oh, she doesn't. She just wanted to thank you, everyone. If you can look at the chats, she's a 20-year cancer survivor and thriver. And we're very happy to have you on board, Dorothy. So thank you for being here. But as a reminder, the Tina's Wish Gala virtual benefit is next Thursday. None of this could happen without fundraising dollars. So to the extent you can participate in that, be great. Otherwise, we look forward to seeing you on the next Roundtable Researcher Consortium presentation, and thank everyone for your time. Thank you, doctors, and thank you, Tina's Wish.